So in this session, we're going to look at covalent bonding and then covalent bonding with carbon as well. So please make sure that your phones are off so as not to distract you. You've not got any music on or the TV on in your background, and you've got a pen and paper to take notes as well. Let's begin. So covalent bonding happens between non-metals. So those are the elements on the right-hand side of the periodic table. And they normally form, for ionic bonds, they form the negatively charged ions. This time they can't form negatively charged ions because they'll repel each other. So to bond them together, we need to have a different type of bond. On this, now see, both atoms need to gain electrons to have that full outer shell. They can't gain it from one of the other atoms, so they decide to share the electrons instead. Now, one covalent bond is one pair of shared electrons. So one bond equals two electrons. Two bonds, so two covalent bonds, would be two pairs of electrons, or four electrons in total that they're sharing. We've got hydrogen. We can see that it is bonding to make a hydrogen molecule. So both hydrogens need to gain one electron to have a full shell. They're only filling up that first shell, so they only need two electrons in there. So they need one more each. And they share an electron with the other hydrogen atom. Both hydrogen atoms now have two electrons in their outer shell. We can see them on here. We've got 1, 2, both being shared. That means we've got one covalent bond in a hydrogen molecule because we've got one pair of shared electrons. Let's have a look at another one. So we're going to have a look at oxygen now and how oxygen atoms form an oxygen molecule. Got a nice drawing here showing us what is happening. Notice we've got the dots and crosses this time. So both of the oxygen atoms need to gain two electrons to have a full shell. They're in group 6, so each one has 6 electrons in its outer shell. They both want two more, and we can see here how they've done it. So they will share 2 electrons with the other oxygen atom. Our 2 crosses being shared here, our 2 dots being shared here. Now both oxygen atoms now have 8 electrons in their outer shell. We can count them up: 1, 2, 3, 4, 5, 6, and then 7, 8 from the other oxygen atom, and 1, 2, 3, 4, 5, 6, 7, 8 that we're sharing from this atom. Now there are 2 covalent bonds here because we've got 2 pairs of shared electrons. We've got 1 and 2, so we have 2 pairs of shared electrons. And you might be thinking, well, how do we draw covalent bonds? I'm going to go through a little method now just to try and show you. We've got a question here asking us to draw a diagram to represent the bonds in a chlorine molecule, or Cl2. I've got 2 chlorine atoms. I'm thinking, well, how on earth do I do this? I'm going to follow these steps. I'm going to draw all the atoms out with their shells overlapping. So I've got one chlorine and another chlorine, and I'm drawing their shells, and I'm going to make sure I've got them overlapping. I'm going to pick one atom and work out how many more electrons it needs to get a full outer shell. And they're both chlorine, so it doesn't matter too much which one I pick. But we'll go for the one on the left. So it already has 7 electrons. It's in group 7. I need one more. I need one more electron to get a full shell. I'm going to draw that many crosses in the overlap. Okay, I need one more. I'm going to draw one cross in the overlap. Oh, this is easy so far. Next to each cross, draw a dot. Okay, I'm going to draw a dot next to it. Go on. So far, very, very easy. Ah, those are my shared electrons. Crosses are from the atom I started with. The dots are from the atom I'm borrowing. Ah, so my cross is from this atom. My cross is there, and my dot is from this atom. I need to draw the rest of the electrons on the shell. Okay, so I need to draw the rest of my crosses on here. So this one has 7 electrons. I've drawn one cross already, so I need to draw 6 more. 1, 2, 3, 4, 5, 6. That was easy. I'll draw my dots now. Again, it's chlorine. I've drawn 1 dot, so I need to do 6 more. 1, 2, 3, 4, 5, 6. I'm just going to check that they've all got 8 electrons in there. So I've got 1, 2, 3, 4, 5, 6, 7, and this shared one, 8. Other one, 1, 2, 3, 4, 5, 6, 7, and my shared one makes 8. So I have 1 covalent bond. Oh, right, I'm going to have to do another one now. Let's have a look. So I need to draw a diagram to represent the bonds in a nitrogen molecule. Now, do have a go if you reckon you could do this yourself now from following those steps. If not, we're going to go along with it. So, first off, I need to draw my atoms out with my shells overlapping. So I've got a nitrogen, and my shells overlapping. Easy so far. Pick one atom and work out how many more electrons it needs to get a full outer shell. So I've got nitrogen here. So at the moment it's got 5 electrons. To get a full shell, so that needs to have 8. So from 5 to 8, I need 3 more electrons. I need to get 3 more electrons on there. Okay, I reckon I can do this then. So my next step, draw that many crosses in the overlap. So 3 crosses. 1, 2, 3. Still easy. Next up, I'm going to draw a dot next to each cross. I should say dot there, shouldn't it? I don't believe I didn't notice that. Yeah, that's right. This is me not being able to read very well, isn't it? There, I think. So I know how a lot of you feel that can't read all these things well and get mixed up. So next to each cross, draw a dot. That's what I've done. Yeah, I've done it right, haven't I? So they're my shared pair of electrons. And I need to draw the rest of my electrons. So my nitrogen here had 5 electrons. I've drawn 3 crosses. So I need to draw 2 more. Done that one. And on this side, I've drawn my 3 dots. So I need to draw 2 more. I'm now going to check my electrons on each one. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. And 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. I'm noticing here that I've got 6 electrons. Well, it's 3 pairs. On this bit, I've got 3 covalent bonds. Another way for saying 3 covalent bonds would be a triple bond, because I've got 3 of them. So absolutely fantastic. Brilliant. Well done if you got that as well. Now going to look at one more. So drawing a water molecule. This is different now because I've got H2O. They're not the same atoms. But first off, I'm going to draw my atoms out with their shells overlapping. I'm going to draw the one I've got least of in the middle. So I'll have my oxygen in the middle. I'll draw my hydrogens on each side. And pick one atom and work out how many more electrons it needs to get a full shell. I'm going to pick oxygen because it's the only one I've got 1 of. So I've got 6 electrons. I need 2 more electrons. I need to get 2 more electrons. So I'm going to draw that many crosses in my overlap. Now, I could draw both my crosses on this side, but I've got nothing on that side. So I'm going to divide it into 2 and draw 1 in each one. Now next to each cross, I'm going to draw a dot. There we go. I'll draw my dots. They're my shared electrons. And I need to draw the rest of my electrons on. So I'll do my oxygen first. So I've drawn 2. I need to draw 6 more. So I've got 1, 2, 3, 4. Oh, sorry, I need to have 4 more because I've already drawn 2. So I've now got my 6 electrons from oxygen. 1, 2, get the pointer on there. 1, 2, 3, 4, 5, 6. And my extra 2 electrons, so 1, 2, so 7, 8 from my hydrogens. My hydrogens I've already completed. They've got their 1 electron, this dot here and here, and they've got their extra 1 they're borrowing or sharing with oxygen, the crosses, giving them a full shell of 2 as well. So well done if you followed that. So, little secret trick going to let you in on. You can work out how many covalent bonds an atom will form by seeing how many more electrons it needs to get a full shell. So elements in group 5 need 3 more electrons. They'll form 3 covalent bonds. Elements in group 6 need 2 more electrons. They will form 2 covalent bonds. And elements in group 7 need 1 more electron. Well done. So they will form 1 covalent bond. Fantastic. Well done if you got that right and worked out the pattern there. We're now going to have a look at properties of covalent bonds and molecules. So a covalent bond is very, very strong. It takes a lot of energy to break it. It has very, very high amounts of energy to break those bonds to form a different compound. Now, substances can be made up of lots of covalently bonded molecules, all interacting together with those intermolecular forces. Now, they have very low melting and boiling points. The reason why is those intermolecular forces between the molecules are very weak. So it doesn't take a lot of energy to overcome the intermolecular forces. Got a little diagram here showing. So we've got 2 oxygen molecules. These parts here are our covalent bonds. Very, very strong. In between them is a very weak intermolecular force. That's why we don't often see liquids with substances that have got covalent bonds. If we do, they have very, very low melting points. It's very rare that we see a solid one as well. If we do, again, they have a low melting point, especially compared to our metals or our ionic compounds. Now, carbon can form covalent bonds as well, and it can form covalent bonds with other carbon atoms. It's only got 4 electrons in its outer shell. It can form up to a maximum of 4 covalent bonds. Now, when it does form covalent bonds with 4 other carbon atoms, we get a very strong substance being made, and that is diamond. In diamonds, every carbon atom is covalently bonded to another 4 carbon atoms, which are also bonded to another 4 carbon atoms. Because covalent bonds are so hard to break, it makes diamond one of the hardest substances in the world. Okay, nice little picture of a diamond there. If you're interested in buying that diamond, found it online on a website, costs about £98,000 for that particular diamond there. So very, very expensive because they're so rare. Now, carbon can also bond with 3 other carbon atoms. When it does that, it forms something called graphite. In that case, we have a spare electron going around. And that electron is not involved in a covalent bond. It's known as a delocalized electron. So we have carbon bonds with 3 other carbon atoms, and we get them now in layers. We get sheets of covalently bonded carbon on top of each other. And because we've only got 3 covalent bonds, graphite is softer than diamond, and the layers can slide off each other, which make it very useful for things like pencils, because we can then write with it. It also conducts electricity because of those delocalized electrons that are free to move. Finally, we have fullerenes. And a fullerene, each carbon atom is covalently bonded to 3 other carbon atoms. And a fullerene is a molecule of carbon atoms that have a hollow shape. They can be tubes or they can be balls. The first fullerene we discovered was C60, so carbon 60. We called it Buckminster fullerene, named after this guy here. He didn't find it, but that guy is called Richard Buckminster Fuller. He was an architect who designed buildings that looked like the one you can see there. And that happens to be very similar to what C60, or Buckminster Fullerene, looks like. So they named it after him, in honour of him. We've got lots of different types of fullerenes, though, depending on the number of carbon atoms we have. And they are all hard for their size, they're very lightweight, and they also all conduct electricity. So loads and loads of uses for them. So, some important things to remember. Covalent bonds are between non-metals. We can't get a metal and a non-metal, it's got to be between non-metals. The atoms share electrons to get a full outer shell. And the covalent bonds themselves are very, very strong. Thank you very much for listening. I'm sorry this was a longer video than normal, but hopefully it's got a lot of important things in there and practice for you to do. Don't forget to subscribe to the channel and have a great day. Take care. Bye-bye.